Hey everybody, this is Paul Mamakos with Ocean Cam Space Corp here with Davinci, and you're welcome to introduce yourself and go forward. Go ahead. Nice to meet
Hello,
you.
everybody. I'm Davinci Machen. So, as some of you have already learned in the chat, so there's a couple things that I've been working on, and I think it's pretty exciting. I've been working on them both for a very long time, since like maybe 2014 or so, like that. And I think I got something exciting. I think not sure. I haven't really put all the aspects into the idea. It's still kind of theoretical in a way and in design phase. So first off, like I mentioned in the chat with the rocket engine that I designed, it's a what I would call a vortex rocket engine. Although it doesn't create a vortetic internal pressure, I really got the it's kind of funny. I got the design or the idea from a vacuum cleaner from Bison vacuum cleaner. And there's multiple ports in it. And if you reverse the polarity, you can actually get more pressure through the vacuum than your regular polarity by reversing the motor engine and stuff and placement of the cartridge and whatnot. Um, Hello, Stephanie. Thank you. So I got the idea from that, and it's just been basically on paper, and then I was self-taught on CAD program, and I've been basically revising, and just coming up with different ways of trying to design this to make it better in a way, without having to go through financial testing and struggles. I've been trying to really find a three-dimensional animated simulator, so that way I can implement the design into it and add the values that's needed: air pressure, combustion pressure, forces, material thickness, pressure, heating, and friction, and everything else. And it's really kind of a dead end on that one. There's a couple of them like Blender and such, and they're just not really user friendly for me, like SketchUp Pro. That's what I use, 2007 model of the SketchUp Pro. So let's see. So the design, how do I flip my camera? Oh, it's not
Looks
gonna
good.
let me. It's not gonna let me.
Okay.
So I'm gonna have to turn this around. So if y'all could see, this is the bottom of the combustion assembly. So there's 8 nozzles here, all right? So when we flip to the top, we have these are the pressure plates, and that has the internal fuel line, fuel injection line, and stuff like that. So there's 8 of them, and I used a spark plug, an automotive spark plug, as a reference to an igniter. I hate using a touchpad, but I have 2 lines on there. Let me do this. This would be better for you. So this is what it looks like on the inside. You have your oxygen and your hydrogen, or your fuel, whatever it may come to be, and then the ignition source would be in the center. If we pan back this way to the bottom of it, it's still kind of incomplete. You have all these ports. You have oxygen on the inside and fuel on the exterior. And I designed my own fuel injector, a coaxial injector. Let's see. Oh, really? How do I zoom in on a fucking mouse pad? But it's just like the Copenhagen swirler injector, and that's really what I kind of referenced it on. Just I added more slight angles and actually vortex. Let's see, swirl rocket engine fuel injector.
You go to
And
view and then zoom in, maybe that way. See it?
oh well,
Tell.
this is the coaxial. Is that it? Come on, there we go. This is a cutaway view of the Copenhagen swirler injectors that were made by Germans engineers. Now that I know how to zoom in using the mouse pad, we're going to go back to our injector.
Maybe just once more, give a brief summary of what's going on here, what we're looking at, and what the overall summary view.
Okay, so what we're looking at is basically a fuel injector of a rocket engine that I've designed. And I'm trying to zoom in on it on a touchpad, which really sucks. And so we're going to go and see through it. As you can see, I have a lot of friendly, and that's as far as you're going to. So let's cut away. No, not that one. Damn it. The hell. I need this one. And this one. So if you can look, there's a lot of friendly angles in there. And it's not finished. Oh, there we go. Fucking A. I hate touchpads. So I'm sorry, guys. I can't see my screen. So you have your fuel that comes in on the side and your oxygen that will come in to the center. And what it does, it's like a fine spray that comes out right here, and it mixes the fuel.
It reminds me of a ramjet engine or something like that. Does that make any sense?
It does. It does. Okay. And I studied Scram and Ram, and there's another one that I've designed in the past. I kind of mixed the two, and that's kind of what I've been doing. Really, like with the wastewater treatment power plant, the technologies exist today. All I'm doing is combining those, a water treatment facility and a power plant, a desal, in a more modernish way that's cleaner by using electrolysis. And by using electrolysis, you could separate the atomic level of liquid by turning H2O into HHO, separating liquid from the solid matter.
Cool.
Then you combust it, turn it into heat and steam, and it goes to a turbine. And instead of that heat and steam escaping into the atmosphere, you run it through a condenser coil. It could be a copper coil like moonshiners use. As long as it collects the driplets, then you have atomically purified water. And so you could send it out. On the other hand, with the steam turbine, you hook it up to a couple electric generators, more than one, so that way you can maximize efficiency, and you're producing whatever power by per one. So let's say figuratively, one engine motor is producing 12 volts. So you hook up 3, you're producing what, 24, 30, 36 volts off of one turbine. So you're maximizing efficiency. So you're combining 2 facilities into one, and the technology all exists. And it's really simplified. Same with this rocket engine that I've designed. So you basically have 8 ports, combustion ports. So say one port produces 1,000 psi. You times that by the 8, that's 8,000 psi. And then it goes through another choke point, your main exhaust nozzle, and with the right ratio, you can actually double that combusted pressure in that vectored exhaust, doubling that pressure. So 8,000 psi turns to 6,000 psi or 16,000 psi. And so if I can get some help completing the design phase, then I can get a tangible demonstrated model. My little brother owns a 3D printer and has a business of it, which is really awesome. He sent me all kinds of products and stuff like that I help him with. And but yeah, just it's really simplified. It's not like modern rockets where you have all these lines and I mean, you could put sensors on it, and it's just little wires like an O2 sensor, but it's more sophisticated than that, we all know. But it's that simplified. And so it's really cool.
Cool. So have you shown the entire model or design, or is that something you're keeping private, or what's
No, it's really because I've revised it so many times. I haven't really completed the design. I can actually draw it on paper, like what it would look like. But to getting it from paper onto CAD and having a work schedule and 5 kids, it's kind of hard,
Sure.
So, being a security guard, I mean, it has its joys and it has its downs, but it's really awesome. Getting in and learning this stuff was really an awesome turning page in my life. It's just I gotta get somewhere and someone to help me advance it, and then hey, we put some type of GPS module and elevator and everything else on it, we could do like SpaceX does and relight our engines and land it vertically, you know?
Right. Well, maybe about 3,000 or 4,000 people are probably going to watch this within the next day or so. So whatever.
That'd be awesome.
As much as you want to say or invite people to contact you or whatever.
Yeah. I'm absolutely open for the help. Like I stated in the chat, you know, I mean, so what was it, Guy? He's talking something about the patents and everything else. Well, I mean, yeah, patents are good for safety and everything else, but if you get decent people, you can get decent help, and you can actually be successful as a whole than an individual.
Right.
You know. Yeah. So, and that's where this is coming into play. You know, you're opening up your channel, asking for entrepreneurs and inventors and stuff like that to go on and whatnot. And I think that's awesome. It brings out that private sector deal, you know, that entrepreneurial advancement, you know, right. Which is cool, really cool. You know, that's why I kind of dove in it, and I was like, hey, you know, let's get it going. So hopefully we can get the awareness out and I can get some help, and it can be, instead of me, it could be we.
Yeah, great. That's all what I'm all about, collaboration and sharing the info. If you want to show it or explain it another 2 or 3 times, you're welcome to do it. Whatever. It's up to you.
Yeah. If anybody wants more detailed pictures, I mean, you could email me, Davinci 8587@gmail.com. This is just how it's spelled, Davinci 8587. But I would love to get in with the right people and actually make this even like a little hobby and go out in the field and test it. I mean, we can get great results. It's pretty much what SpaceX is doing, but on a much bigger scale. You know?
Yeah, I know a couple of people who have been making models of stuff and who have also sent me 3D models of stuff and who have 3D printers already also. So
right,
you never know who's here in the community that might want to participate. You know, so.
Right. Yeah. And I'm all open for it. I mean, if anybody can help me out, then that'd be awesome. It won't be a me anymore. It'd be a we.
Right.
So that'd be awesome. That'd be really awesome.
All right. Is there anything else you want to show, or do you want
to show that was pretty much it. I thought we'd go more into it, but it was a good intro.
Yeah.
It gives a good insight.
I don't know if you have more time. I'll take a look. If you want to walk me through understanding what you're doing, I'd be happy to do that, but it's up to you.
Yeah, I mean, that's fine. That's what I was kind of expecting, was the digging of the brain. But I mean, you're busy, and I understand that.
Well, I got time now, unless you're done.
Oh no. Ask
go.
away.
Let's
ask away. Ask away.
Sure. Maybe bring up the picture, and I'll try and understand it, because I used to fly airplanes, and I studied like the 727 systems with the piping and everything, and the fuel flow and all that. So I understand engines to some degree. Do you have any oil or anything like that in there?
A what?
Does it need any lubrication?
No. So I only have the design aspects. The combustion assembly is basically a mixing head. A combustion mixing head with internal fuel injectors, which this is pretty much what that is. So so your igniter will screw into your pressure plate, your combustion pressure plate. Your combustion pressure plate will screw into the combustion port. And this port is all a assembly. So this is the combustion assembly. And on the bottom side, it has nozzles, which exert the vectored fuel and pressures. So there's 8 of those nozzles on the bottom side. I know it kind of looks like shit because it doesn't have the fill in around the nozzles.
So is it 8 around and 1 in the center?
No, so the center is just for weight reduction, so that way it's not completely solid. So on this scale, we're probably looking at a 1/2 inch separation between each port, and this would be like a small scale hobby build if it was to be built.
Okay.
For test, I couldn't finance a fully 12-foot rocket engine, you know. So I mean, something small like within 8 inches I would assume I could save up for, or you know, get something made if I had the right direction to go.
Well, what if a bunch of people from SpaceX who already work on the Raptor engines were watching this? Because this is the Boca Chica SpaceX crowd that watches this channel.
It'd be awesome.
They do the designs and everything, and maybe Elon might eventually watch this as well. What
That'd
would you
be
want
awesome.
to say to them, or what kind of thrust do you get, or what kind of liquid cooling might you need, and stuff like that for full scale? Full scale, what would that be? Yeah.
Theoretically, I guess the only thing that you'd really have to change out would be the fuel injection nozzles for the fuel injection, so that way you can burn different ratio or different types of fuel. I kind of built this to be made to run different types of fuel: methane, hydrogen, oxygen peroxide, kerosene. It really, like a car engine, it's kind of depending on its fuel injection, oxygen ratio, and you can get combustion. If you can create enough heat with the spark plug, then you can create combustion. So it's like, what is it? Someone told me that the 3 things that you need for a motor to run is air, electric, and fuel. You can get those 3 things going, then you could pretty much get an engine going.
Air, electric, and fuel. Is it a hypergolic combination, or is it just you just need an igniter?
Well, running an aerosol gas and having it hypergolic would be the best way, because you can compress more, like turning aerosol oxygen or aerosol hydrogen or methane, and you sub-freeze it. You're condensing it to its most max form, and then you can pressurize it and then get the most out of it. It's really all whatever the user wants it to be run on.
Awesome. Multi-fuel, that's awesome. Would it work in space? This will work in space too, right?
As long as there's oxygen to complete the spark and combustion. Yeah. So if you have the
if it were a hypergolic, would you need the igniters also, or you'd still need the igniters?
I'm believing that you'd still need the igniters for reigniting. Cool. If you're running oxygen, which more or less in zero or in space, you're going to need oxygen to complete the combustion phase. So yeah, I would assume so.
Okay. How is this different from a ramjet engine? I know that would have the nozzle in the center, and it would kind of deflect that going out. Yeah.
A ramjet, isn't that the open fin, or is that the like a J-shaped one?
Yeah, I think so. Yeah. I think so.
Where's J-shaped, and it's like a sputtering, popping ignition type deal, where it's like pop, 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 like with the V2. No, not V2. The Germans tried using it back in the day in World War II. It was like a little curved tube with wings on it. That's pretty much like a backfire compressed deal.
Or maybe just describe how this one, how the nozzle redirects to gas or whatever, and how that pushes out, and how that works.
Well, I mean, to create pressure, you have to channel pressure, or to create a vector in exhaust, you have to channel it right, just like combustion. So it's a controlled explosion, and it's being channeled back down a tube, and you can vector a pressure in a direction. Just like a regular rocket, you have your mixing head, your combustion, and then it goes through the throat to your exhaust, and then you get your forward momentum depending on how much combustion and pressure you can produce and vector it out without blowing up. So it kind of works on the same principle. It's just I tidied it up a bit. I really can't really explain it. I never really tried to explain it to anybody, to be honest. This is like the first time I really came open with it, and like, all right, I'm gonna do this, whatever. If it happens, it happens. If it doesn't, it still stays on the computer in my mind. I'd love to pass it down and see if I get old enough, I could pass it down, and maybe someone younger can tidy it up and make it better.
Yeah.
Cool. You know,
I can guarantee you there are kids here that are going to watch this who have 3D printers or who already make models, because I talked with 2 or 3 of them already. So,
and every kid I come across, I talk to them about the STEM program. Hey, you know, have you heard about the STEM? It'd be something great to get into. You know, even as a teenager, get into it. The more you know, the better you're off. And so I try to get that out. That, you know, our space community awareness, SpaceX, even.
Good.
You know, SpaceX, Blue Origin, ULA, and such like that. I try to get everybody out, although I'm not a big Blue Origin fan. But hey, congrats on putting William Shatner in space. You know.
So there's 3 parts that you were saying to each of the engines, and the igniter screws into the first part, and then that maybe screws into the second part. Each of them screw in. Okay.
Yeah, everything screws in. So I used the reference of a spark plug, and that's what I kind of built around of. And then I implemented the idea from the vacuum cleaner with multi-ports, and you know, theoretically, if you can, it's just like a combustion an actual rocket engine. You have one port that combusts, and it goes through a nozzle. So if you could put that on a multi-level and in a radial assembly, it could possibly do the same thing, but the main factors is your combustion ratio to throat and throat pressure exerted out of the combustion assembly into the vectoring nozzle, and getting that throat pressure or that throat ratio right. Would
you be able to turn off nozzles completely and just have the others running? I mean, if the fuel is going simultaneously to all the nozzles, would you be able to cut 1 or 2 of them off?
So yeah, you can use like RC servos and put in implement a command, and you have your valves, your shutoff valves on those servos with a little arm. So it's like when you press up, you can close that valve. You release that that little handle, and it goes back to where its original setting was. So you can actually control with a board or a module or something like that, and actually run simulations, and then, you know, save that and then run the best simulation. Even if you have to combine simulations, you can get the best. It's like a spaghetti chart, and you can get the best result upon anything. You know?
Cool.
Yeah.
So I saw like the 8 engines and the center is empty. Where's the fuel and how does that work again?
Okay, so I'll have to bring it back up. So we're gonna actually zoom in on one of these on by itself with a cutaway. So we're gonna open, and where is it? Fuel injection plate. Yes. Come on. Oh, you're being a pain. Let's see. Open. I don't know why it's being a pain.
For all you watching, I was over at the launch site. I got a whole bunch of shots, and I got the lifting of the GSC tank cover for the final tank there. So I did get that shot. I will upload that footage later tonight, and I wasn't able to get to my phone because they had the road blocked off, but I had my other camera. So I got that footage, and I will be uploading it later tonight. So.
Okay, so from the pressure plate, this is basically the internal view, incompleted internal view of it. So you have your red line and your blue line. Your blue line is obviously your oxygen, and your red line is your hot line, your fuel line. And so this is pretty much what it would look like if it was see-through. You'd have your your igniter right here, your fuel lines here, and then on the bottom side, see, those lines will connect. I just haven't had the time to connect them, and they would be sprayed out of here. So it could go both ways. Like I could run Ys with an injector at the Y, and then have it come into the bottom side of the plate, and then have shutoff valves at the main fuel line entrance.
Yeah,
line
to regulate it, right?
Yeah.
So one of them is oxygen. What's the other one? Just any other fuel, or
fuel. So when you pressurize, you're pressurizing upon pressure. So you have to have that constant pressure going through, even with the turbos, to get that fuel going, and then you can combust it. So you could have those shut off.
What are some of the fuels that you could use for the red one?
Like I mentioned earlier, it depends on. Okay, so I want to try to do like a universal fuel injection injector. So that way, when you twist it, it tightens up, and when you loosen it, it loosens up, spreading your ratio of fuel and oxygen. So that way, you know, you get it. You don't have to, you know, take out these injectors and put new ones in for the different fuel. You can just, like on the carburetor on a lawnmower, you could turn the little screw and you can change up your fuel mixture. Same instance, you could do the same. I just got to kind of redesign my swirler coaxials for that, which I think wouldn't be hard. I just got to get the time.
So that was one rocket engine you were showing there, and again, there's 8 of those, right?
The engine is the complete assembly. This is just one of the pressure plates. This is one of the pressure plates. Yeah. This is the internal view of the pressure plate where the igniter screws into. And then the pressure plate will screw into the combustion assembly. The combustion assembly will screw into the main nozzle.
Yeah, that makes sense. Okay.
Mm-hmm. So that way you don't really have nuts and bolts and extra parts, extra weight. And it really maximizes the look and, you know, I want to say the efficiency of the engine, but it's not been tested yet or produced. So I can't really say much upon the efficiency yet because I haven't ran it through a simulator or a live test. So I couldn't really say what it could produce or what it wouldn't produce.
How is that different from a Raptor engine?
I don't know. I'm still kind of wrapping my head around the Raptor engine and its capabilities because it's under version 2. It's still in its infancies. And we see how the Merlin, you know, evolved, and that's what basically created the Raptor. And now we're at version 2 Raptor and it's a vacuum cycle. I mean, come on. What more can you do? And SpaceX, Elon, the team, y'all are amazing. I wish I could get in. Just doing this, that'd be awesome. Helping design and stuff like that. That'd be awesome. It'd be a lot better than what I'm doing now.
There's a SpaceX.com careers page on a tab on that SpaceX.com website. So you could probably apply if you haven't done it already. You know,
no, I haven't because I'm not accredited on paper. I don't have any college degrees. I'm pretty much self-taught, and I'm still learning every day. It's not my quote, it's someone else's. If you educate me, cool, I'm open-minded to so. Please enlighten me. It's really awesome. You know, cool. Getting to know this stuff and getting it out. That was like the biggest weight off my chest right there. Yeah.
All right. So maybe just a third and last time, maybe do an overview of the entire thing, not just the nozzle, and as much as you're willing to say about the overall design and how it's special, maybe.
Let's see. Is this it? I think I found a better representation. Okay, so I got basically a copy of each. Come on, you gonna give me this? You're gonna be ours. Yeah, it's not gonna give me it. All right. So this is right here is basically a cutaway see-through of the pressure plates in the combustion assembly position. And so this is the assembly of all the nozzles. And I don't have, well, yeah, I do. I do have the igniters. It won't. There we go. So yeah, that's what it looks like, see-through like that. So you have this outer ring, and that's the setting for the combustion assembly. And if we pan down, we have those ports right there, if you can see that.
Yeah.
And so this assembly this assembly right here will screw into a nozzle just like this, just like these small nozzles.
Screwing on the top or on the bottom, do you think?
So the combustion assembly will screw into a main nozzle. So there'll be a big old nozzle right here.
So that's the part on top that we're seeing on top of those nozzles?
Yes.
Okay,
this would be like a mixing head and combustion assembly in one.
I got it.
So you have the mixing head on top of the engine, then you have the combustion, and then you have the throat and vector. Well, I'm combining fuel injection, mixing head, and combustion all in one. And I'm doubling that pressure.
What was that last part? You're what?
I'm doubling that pressure.
I got you.
So each one of these produce, figuratively, each one of these produce 1,000 PSI. So that's 8,000 PSI total. And you put this assembly inside of another nozzle, it doubles that pressure if your throat ratios are right. And that's
cool.
That's the Vortex rocket engine that I'm
okay. So you had that thing that goes on top of the nozzle. It'll help double the pressure. And what are you cutting out? What's that piece that you're getting rid of?
So the piece that I'm getting rid of, really, what do you mean by that?
Well, this design combines a few things and simplifies something, I think you were saying.
Yeah. So I wish I had it. A regular engine, on top of the engine is where the fuel goes in and the oxygen goes in. And you have these little ports like baffles that spray the fuel out. And that's your mixing head. Well, you have igniters in that chamber there, and that's what makes the combustion. And it channels it down because one end is a dead end, and you have a channel that goes down and it goes to a squeezing point. Well, that's how you create that pressure from combustion, channeling that pressure through that throat, and it gets exhausted out. And that's how you get your forward momentum or force pressure. So I'm basically simplifying the mixing head and combustion. I'm basically condensing it. I'm adding more ports to the same engine. So instead of having this bulbous engine with one deal, I have this bulbous engine with multiple internal engines. Yeah. And I'm basically producing internal pressure like a regular modern rocket. I'm just channeling that combusted pressure and reusing it basically to double that pressure out of the main exhaust nozzle.
Cool.
Yeah.
Yeah, and if you're able to draw any diagrams in the future with that, or there will be other people here who understand what you're talking about. And so I'm excited to see what happens.
Yeah, me too. I hope I really get some good leads on, help and furthering this, and even just to get it tested for, pardon my French, shits and giggles, just to see the capabilities of it. I mean, it can evolve into something different with other minds. This is just the basis of one mind. What could be the possibilities of 5 or 10 other minds?
Right.
So that's kind of where I'm at, and that's why we're here. So hopefully it's a good stepping stone for the channel and myself. We can all get something going for the future of humanity, not just for ourselves, but our children and their children.
Okay. So you mentioned where you're splitting the water and stuff. I don't know if you can say a little bit about some of that stuff.
Oh, the wastewater treatment power plant. Okay, so yeah.
Well, I mean, sticking with this engine, you were splitting the hydrogen and the oxygen, I think.
So we can actually miniaturize the wastewater treatment power plant, and our human waste we can actually use a lot for. So we could turn our human waste into drinkable, potable water. We could use it to put in our plants and stuff like that. But we haven't really found a way to use it as a small ratio to produce fuel with the same process. So just like the wastewater treatment power plant on ground, you're using the same implication to make fuel drinkable water, electricity in one unit. And so by doing that, and it has zero emissions, for the record, absolute zero emissions.
What's the method of doing that? Because I know Elon has like $100 million carbon capture thing, right?
I know, yeah. Electrolysis.
Okay.
So you could actually use low amp, high volt, and still use low power as a general to produce atomically purified water, electricity, and fuel and oxygen. You just got to separate it. And you get a separator, and you put it all in 2 tanks. You got your safe pressurized hydrogen in a tank, and you have your oxygen in a tank, and then you have a water storage as well as fuel storage. So you could take portions out of that, run it through an igniter, like a what is it? Like a heater, a gas heater, type deal, to ignite it and turn that aerosol into a liquid, and then you get your liquid water and you run it through a condenser, and you get your droplets, and just like moonshiners do, they do the same thing, just with different materials, different setup. But I mean, you run it through a condenser and it becomes water driplets, and then it goes into a storage tank. Then you could ration that out and whatnot, and everything's about rationing out when you're in space. So as long as you could ration everything out right, then you could actually go places, with the right efficiencies of engines, fuel ratios, thrust to weight, and everything else. I mean, those are big numbers to be trying to implicate in a mine to go somewhere. So to do that, you have to maximize your efficiency, your power, what you waste, so that way you can get where you need to go. So by turning 3 things into one, you actually maximize a lot of things. You create room, more storage room or whatnot. You're producing more than one thing with one thing, and yeah, it's endless. There's so much that one thing or multiple things can turn into one thing, and the technology exists today. It's reverse engineering that and trying to think of the implications that it can apply to.
Can you focus on what splits the water? Because that is the main thing, I think, at cost. How do you do that?
Electrolysis is okay. I can't get nothing better. I would use stainless steel. There's many different ways to create a hydrogen generator. I've seen stainless steel wool, like scratchers for your dishes, and a little soda top in a jar. It just depends on how you build it and whatnot and what you use. But you use the plates and you set them side by side, positive, negative, positive, negative, positive, negative, positive, negative, so on and so forth. And the plates will have an interaction, and the electrolysis process, it'll separate the H2O to make HHO. Then when the HHO comes up, it goes through a tube, and you can go through a bubbler, which is like a flashback. Which means that in case of ignition outside of your generator, it doesn't flash back into your generator and blow up your generator. So your bubbler is like a safeguard, a buffer, if you will. And you can actually go from the bubbler and pressurize it in a balloon. And whenever you ignite it, it turns back into like a steam droplets, kind of like a heavy steam, and it goes down as little itty bitty water droplets. So you have your stainless steel plates, and there's a way to apply the electricity, which I don't want to say because the kids, I don't want them blowing themselves up. So there's a way to add the electricity, and the electricity, the reaction with the stainless steel plates will diffuse the water H2O to HHO. And that's how you get aerosol, hydrogen, and oxygen. Yeah.
Cool. That sounds good. Yeah, I've done a little bit of electrolysis in the past, and I think I needed some salt to make it work at the basic level that I was doing. I just took some of the electrical from a battery or from the wall, and I put it in some water, right? And then I saw some bubbles.
Yeah. Human urine has that salt in it,
Okay.
which the salt in the water, it adds conductivity, which adds it's easier to have that reaction between the stainless steel plates, if
Yeah.
you will.
Yeah. Urine is just like blood, so it's basically the
R-
same thing without the hemoglobin. So I'm with you.
right. And
Cool.
so you won't have to add that sodium or that salt while on orbit or in space. It's
Right.
already
That's what they've been
naturally
doing in
there.
the space station. That's right. Yeah.
Right.
Recycling their fluids. Cool. Cool.
Yep. They're just missing the part of the electrolysis.
Cool.
Oh, there's another thing I'd like to talk to you about
Yeah. Yeah.
for all you growers who like herbs, plants, weed, whatever. If you like being outdoors and growing, let me get a colored one. So me and my little brother, we designed this in house and 3D printed it. This is called a grow hanger. You can hang it indoor or outdoor, and you can grow your plants in it. Let me set this down real quick.
What'd you call it?
A grow hanger.
Oh, cool. I grow stuff too. So I've been growing for many, many years, but not many marijuana and stuff. But I do respect that. Go ahead.
But this is your net cup, and this is what you put your germinated seed in and your rocks. There's no soil. It's a DWC cracky system, and this is what you put your water in. And you can hang it indoor or outdoor, and
Cool.
you just slip it on and hang it, and it grows. You get a pH monitor and whatnot, and you got to put nutrients in your water. Frequently change it out so you don't create root rot. But the original idea, we called it the Diamond Earth. And if some of y'all remember, NASA put out a contract for food in space. And that's what this was on. At first, it was a little balloon, and it was real compact, small. We could put 250 in it, not weigh a pound.
Wow.
Yeah. And we didn't get the contract because we didn't have the liability insurance, and we had to be incorporated to have that liability of insurance as a company, not for the product,
Man.
but it was for the product. So we were pretty much disqualified. So then
Tough.
we evolved it to this.
That's
No,
so easy to do, though.
we persevered, and we kept pushing, and this is
Wow.
what we come up with. And yeah, so it's really simple.
Are you guys applying again for the contract, or is it over?
I believe it's over. I think it got finalized May or June this year.
Okay, cool.
Yeah. But
Was that an SME thing, or what was that? What kind of where'd you see that?
it was the food in space. I'm not
Okay.
sure. Yeah, my little brother did all the paperwork. I just helped him design and come up with the idea. And we sat in our own little Discord chat, just rambling it on while I'm at work, and just, yeah, man, we could do this. Well, we can't do that if it does this. And we were just, bouncing back and forth and whatnot. We did a lot of good collaboration. But
All
yeah.
right. Cool.
Yeah.
Well, yeah, thanks for coming on. If you ever want to come on again, or if you want to say something else, go ahead. Yeah.
Oh, thank you for having me. I know you're a busy person, and I love what you're doing. I watch your footage every time I'm at work, sitting there waiting for FedEx employees to come in. I'm just sitting there like this, watching Ocean Cam. Yeah. So, thank you for having me. It was awesome. That was a lot of weight off my shoulders. And if anybody has any questions, hit me up. Davinci8587@gmail.com. I'm also on Discord. I don't know. You gotta send me your Discord so I can get in on that.
Okay.
So yeah.
I'll send you.
But yeah, thanks for having me, Paul.
Yeah, thanks, Davinci. What is the? Do you know what the last question would be? Do you know what the thrust from that engine would it be? Similar, comparable, or better than some of the others?
I really couldn't say, and I don't want to promise something or say something that might bite me in the ass later. So really, it's. I mean, I want to say it'd be equal as the Raptor, but I don't want to get my hopes or everybody else's hopes up and it come out being nothing, no more than a vacuum cleaner, So that's where I'm at with it. It's still in the design phase on CAD, and at the moment, that's where it's at. There's no realistic physical numbers that have been put on it. It's all been figurative, hypothetical, theoretical. So I mean, I would like to make it a reality and at least test it once or twice.
Yeah.
And possibly go from there. If it's successful, then we can up the scale, or we can revise and try to make it better and more efficient, and go from there. I mean, there's no limit. The possibilities are endless with the right people, and Elon did it. Why can't anybody else? You just got to talk to the right people, and the right people will help. So. Yeah.
Well, if you send me any links to any images or anything like that, I can put it here in the description of this video. Just whatever you want to send, if anything.
I sent you the ones I did in the email, so if you want to go ahead and post those, you can.
Yeah, I don't know if you have a Google Docs you can put it in and then send me the link, or just send me the whole thing and I can upload it somewhere and whatever.
I'm a very simple person.
Just photos or whatever.
Yeah. Like I said, I got to get a new computer to continue my work. Yeah, I know, right? It's a every person's thing, getting new hardware. But yeah, my woman deals with all this stuff and everything else.
Maybe a GoFundMe or something like that if you need more cash. I had one of those for a while. I don't currently, but I don't know if you have something like that, or if you do in the future. Send me a link.
I don't at the moment. I don't want to ask for money. I'd rather ask for enlightenment and knowledge to progress this in the right direction. And if somebody's willing to help out and progress the idea, whether it be mentally, physically, financially, materialistically, with material to make the engine, cool. Then now all I have to do is find a machinist to machine this big old bar stock.
Right.
Cool.
Well, I know someone who might be able to do that where I am now. But anyway, yeah. So whatever, I'll show him this video too. Yeah, if any of y'all see this video and you want to get in touch, you got the email there, and I'll post whatever info I get, and go from there. Yeah. Thanks for reaching out and saying hello.
Awesome. Thank you.
Peace. Namaste, everybody. Take care.
Have a good night.